Assalamualaikum warahmatullahi wabarakatuh. I'm Indi Rawan. Welcome to Introduction to Artificial Intelligence. And our topic now is about ensemble methods. And we are discussing boosting. So boosting is a way to increase the performance of a machine learning algorithm. And especially in this case is we can not we can reduce bias, yeah. So because in bagging we can reduce the variance, but it has no effect on bias. But in boosting, hopefully we can reduce the bias. So what does that mean? The principle of boosting is that we can boost a set of weak learners to become a strong learner. So what it means is because models and data, they are not the same. A prediction can classify the right ones, but also the model can classify and it gets it wrong. Okay? We call them misclassified. So what boosting does is that we are giving more importance to the models that can distinguish the uh, the wrong ones, yeah, um, better. Okay, so for example, we train using all of the data and then we test. Now it turns out that record 4 and 7 are wrongly classified. Okay, so we have 10 data, and then we have that the output of the data 4 and also the output of the prediction of data 7, they are wrong. Now, so what can we do by using boosting? So by using boosting, we can do training, but in this case, instead of training using the original data set, now we will create a new data set. We generate a new data set, but we put more significance. We put more weight on the data that was wrong, that were wrong. Okay, so if you notice here now, the data 7 has appeared twice. Okay, because it's usually classified wrong, so now we put this twice in the new data. But after we train here using this training data, what we do is that we still test the training result using all data. Okay. So what happens after that? Now what happens? It turns out that the results of that is that, hey, we get the data 7 is good. So now we do the same thing, and after that we generate a new data, but then we increase the weight of, as you can see, there are two wrong outputs here. So we increase the weight of data 4 and we increase the weight of data 5. And then after doing the training, and then we test to all data, and yeah, it turns out that now we have a better training results than before, right? So now we can correctly classify 5, we can also correctly classify 7, but we are still wrong on data number 4. So we can do that again, and then we increase the weight of training data 4 even more, and yeah, until it's is enough. Yeah, maybe we cannot get 100% accuracy, but we can increase the accuracy incrementally. Okay. So there is an algorithm that's called ADA boost. So this ADA boost is an algorithm that works. First, all of the training data, all of the records in the training data has the same weights. So if we have 10 data, that means the weight will be 0.1. But then we have several rounds, and then we do a bootstrapping sample. So we do the bootstrap just like before, and it's based on the weights. At first, because the weights are the same, then usually the bootstrap training data will be quite uniform, it will be quite random. And then we train a classifier, and then after that we increase the weight of the records that are wrongly classified. And the other way around, for the records that are classified correctly, we'll have the weights decrease. So why is that? That's because usually the the data that are classified correctly, they are the easy ones. Yeah, they are the easy ones. So the weights can be decreased. And we do that, we do each round until we have a good error rate. So the error can be below the threshold that we want, or we do it until the maximum of rounds. But it can also happen that the error rate is getting even higher. So if we get a higher error rate, then we need to start over, because that means the boosting is not working. It's actually making the training even worse. Okay. And then the final prediction is the weighted average of all of the classifiers with the weight representing the training accuracy for that classifier. So this is the pseudocode for ADA boost. Now we can see that boosting has advantages. So there is very little code required here compared to a new machine learning algorithm. So boosting is simply rearranging the training data with more weights given to the wrong classified ones and less weights for the correctly classified ones. And the nice thing about boosting is that boosting will reduce bias. Yeah, so I would say that this is not correct. Yeah, so actually oops. So not variance but bias. All right. Okay. So boosting reduces bias. Uh, Begging will reduce the variance. Okay. So the disadvantage is boosting is sensitive to noise and sensitive to outliers. So there are some cases where actually boosting will increase variance, but it's usually it will reduce the bias. Right. So what is the conclusion from begging versus boosting? So begging is combining by consensus, and it is a parallel ensemble because each model is built independently. So if you recall, with begging, we actually build, we actually do the bootstrapping or creating the different training models, training data sets independently, and then we can run each of the model independently. There is no relationship between model 1 and model 2 and model 3, there is no relationship, and it will they will be merged, or they will be ensembled or averaged uh, to the final result. And bagging will reduce variance, but it does not reduce bias. And boosting is combined by learning. Okay, and what it does is sequential ensemble, because it will do training based on the results of the previous uh, models. And that means that you cannot build a model, or you cannot train a model before finishing the previous model. Okay, and then boosting will decrease bias, but it it does not reduce variance, but what it does is that it will decrease the bias. So when should we use bagging and when should we use boosting? So bagging is if we have a model that is high in variance but low in bias. Okay, so for models who are complex, and the example of a tree-based method is random forest, which will develop fully grown trees. And boosting is suitable for models that have a low variance but high bias. Okay. So an example of ensemble method that is using a tree base is called gradient boosting. So we can see that ensemble, if we are not using ensemble, the single classifier is like this. So we have a training data, and then we generate a single model to predict the output. But when we are using bagging, it's actually from that single training data we create different bootstrap training data, and then we train them independently. So this is bagging. Now for boosting, so first we generate from this training data, we generate a model, we train a model, and then based on the accuracy of that model, we then generate new training data, uh, and then we train that to generate another model. And then based on the accuracy of that, we generate another training data, and then we train another model. Okay. And if in bagging, all of the models here have the same weight, so it's like majority vote or average. But in boosting, actually, these different models have a different weights. Okay, so for example, if the model here has a maybe 60% accuracy, then it will have that weight. But if this model has maybe like 75% accuracy, then it will have that weight. But if this model has like a 80% accuracy, then it will have that weight. But all of the models here will still be used in boosting, but the weight for the final result will be multiplied by their weight. Okay, but by weighting, this needs to be multiplied and divided by the sum. Yeah? So not just multiplied by 60%, but divided also by the sum of the accuracies here. Okay, so and that's the end of Ensemble for bagging and boosting. So thank you for joining us. I hope you enjoy this video. I'm Hendy Irawan and see you on the next video. Wassalamualaikum warahmatullahi wabarakatuh.